Hello, everyone. Today we're going to be discussing section 6.1, solving quadratic equations using the square root property and completing the square. In this video, we'll discuss the square root property and we'll do problems number 1, 2, and 3. When we look at the square root property, what does that mean? We're trying to take the square root of both sides of an equation in order to solve for x. Notice, when we have quadratics, we have different forms. We could have x squared equals 25, or we could have a binomial squared. So x minus 3 squared equals 64, or we could have a binomial squared with this coefficient. So 3x plus 1 squared equals 48. We'll kind of discuss today how to solve each one of these. If you look at the little paragraph in your notes, you'll see that whenever there's a way to do something in math, there's often a way to undo it. Many operations in mathematics have an inverse operation. The inverse operation of subtraction is addition. The inverse operation of multiplication is division. The inverse operation of squaring is taking the square root. And when we take the square root, we must remember to take both the positive and the negative square roots, as you can see below. So for any non-zero number p, x squared equals p has two solutions. Why is that? Why do we have to say plus or minus? So the whole idea here is talking about anytime I say x squared equals 25. What am I asking? I'm asking you to solve for x. What x value can you plug in to make this statement true? What can you plug in for x to make this true? And the answer is, oh, I could plug in 5, and that makes this a true statement. I can also plug in -5, and that makes this a true statement. Remember, the square root of x squared is not just equal to x. It's equal to the absolute value of x. So if I plug in 5 or -5, I still get 25. All right. So how do I use this property to undo when I'm solving? Let's look at number 1. Solve using the square root property. Well, I think, how do I get x alone? Remember, anytime a question asks you to solve, your main point is to isolate the variable. Tell me what x values will make this statement true. Okay, so I take x squared equals 25, and then I take the square root of both sides. When you take the square root of both sides, you get x equals plus or minus 5. So what x values will make this statement true? A plus or a minus 5. Let's try problem number 2. How do I solve using the square root property? Well, if you have a binomial squared, isolate that binomial first, then you can take the square root of both sides. This is all alone, so I can go ahead and take the square root of both sides. That will give me x minus 3. So the square root and the squared undid each other, and you're still left with what's inside the parentheses, x minus 3. And then plus or minus the square root of 64, which is 8. So this tells me two things. I can add 3 to both sides, so x is equal to 3 plus 8, and x is equal to 3 minus 8. So what are my x values? 3 plus 8 is 11, and 3 minus 8 is -5. There are two x values that will make this statement true. All right. Remember, you can plug those in and make sure you're right. If I plug in -5, I get -8 squared 64. If I plug in 11, I get +8 squared 64. So I know I'm doing it right. Let's do one more together. Problem number 3. What if I have 3 in front? Well, the first step to solving and trying to isolate that variable is to divide. Peel everything off to isolate just the x squared or the binomial that is squared. So the first step here is to divide both sides by 3, which leaves me with x plus 1 quantity squared equal to 16. Now that I've isolated the square, I can take the square root and remembering plus or minus. So x plus 1 will equal plus or minus the square root of 16, which is 4. Then I can subtract 1 from both sides. So x equals -1 plus or minus 4. So what x values will make this statement true? -1 plus 4, which is 3, and -1 minus 4, which is -5. And you could plug them back in and make sure they're right. I hope this helps clarify the square root property. I'll see you next time.